morning, friends. It gives me immense pleasure to be here again for my course, Flight Mechanics. This course is in 4th semester of Aeronautical Engineering at Institute of Aeronautical Engineering, Hyderabad, India. I am Dr. Yagya Dutta Dwivedhi, Professor from IARE, Hyderabad, from Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. My today's topic is performance and mission requirements. So we are here discussing about flight mechanics. In that, the first issue is the performance. What are the basic characteristics and the parameters to assess the performance of the aircraft, and what are the mission requirement for any aircraft? We have different types of mission for the aircraft, and you can see that in the mission requirement, you will have the range, endurance, landing, takeoff, cruise, climb, maneuver, and so many more. The performance things are there, and there are some mission requirements, which mission your aircraft is to be designed. Like general aviation aircraft, your firefighting, your agricultural purpose, or passenger or cargo or fighter aircraft, combat aircraft, and different types of missions of aircrafts are there. So these are things we are going to discuss in today's class. So we have some course overview. In that, we will see that course objective, then introduction to flight mechanics, then performance requirements, and the mission profile. These are the topics which I am going to cover in today's class. In previous also I have discussed about the course overview and the course objective. Little I will again touch here in this class. So course overview, just the flight mechanics is the science that investigate the performance of the aircraft as applied to flight vehicle and to provide a clear understanding of related topics, specifically on aerodynamics, propulsion, performance, stability, and the flight control. So if you see about the flight mechanics, this covers these topics of aerodynamics. In this basic lift, drag, and all aerodynamic characteristics has to be understood before we start. Then something about the propulsion also has to be understood, performance also, and then stability and the flight control. These are the part of the flight mechanics. So the course introduces the fundamental principles of aerodynamics and the propulsion for aircraft performance in classical flying stages. This course is the point of confluence of other disciplines of aeronautical engineering and the gateway to the aircraft design. So if you want to design the aircraft, we should not go without the understanding of the flight mechanics. It means the aircraft performance and stability and the flight control. So before going to the design, we go for the aerodynamics, then we understand about the propulsion, about engines, type of engine to be used, for which purpose the aircraft is to be designed, then what type of performance we want, what mission requirement is there for this aircraft, then whether this aircraft is stable or not, and whether this aircraft is able to controllable or not. So these parameters we should understand before we go for the any starting of the aircraft. So course objective is to the fundamental principles of aerodynamics and propulsion for aircraft performance in classical flying. Then the different regimes of aircraft and performance requirements at various atmospheric conditions. The mathematical model for various types of maneuvers, safety requirements during takeoff, landing for better performance and stability. So these are the course objective. It means these points the students should be able to grasp from this course. This is the objectives. Now I will go for the introduction of this course. And in this, flight mechanics is the study of forces that act on aircraft. So if you see the forces, we have different forces here. So normally for any aircraft, we will have the four major forces. The first is the lift. It is a weight. It is mg. Then to counter this weight, we need the lift. Then if it is moving, there will be a drag. To counter this drag, we should have the thrust. So it is a drag, and this T is called the thrust. So flight mechanics is the study of forces that act on the aircraft flight. So these are the forces in the different systems. Their parameters may be, their numbers, their quantity may be different, but these four forces will be acting for any aircraft. This subject is a broad heading that encompasses three major disciplines. So in this, we have the three major disciplines in this course. They are the first one is the aircraft performance, which we are going to handle in this course. Then flight dynamics, it is called aircraft stability and the control, another term. And the third one is aeroelasticity. We will be focusing only on this. So this flight mechanics consists of airplane performance, flight dynamics, aeroelasticity. So these are the things which we have to tackle in this course. So first we will see the aircraft performance. So what is the meaning of aircraft performance? And in this we will be discussing only aircraft performance, and the previous course, which is aircraft stability and control, which I have already covered 1 year back. So if you want to refer the second thing, it is already all the my lessons or lectures are already uploaded in YouTube. You can refer that. So airplane performance deals with the determination of performance characteristics such as range, endurance, rate of climb, and takeoff and the landing distance, as well as flight path optimization. So these are if you talk about airplane performance, this deals with the determination of performance characteristics. So first we have to see what are the performance characteristics such as range, endurance, rate of climb, takeoff, landing. These all things are part of the airplane performance. We will be only handling this part in this course. These parts will be discussed in detail in this course. Now the second is flight dynamics. It is also called aircraft stability and control. You can refer my video lecture in IARE YouTube channel. This you can refer. It is available in YouTube. So flight dynamics is concerned with the motion of airplane due to the internally or externally generated disturbances. So if the disturbance is generated, that time we have to see that how the aircraft is behaving in that condition. Then next is aeroelasticity. In that, if you see that aeroelasticity deals with both static and the dynamic aeroelastic phenomena. Basically, aeroelasticity is concerned with the phenomena associated with interaction between inertial, elastic and aerodynamic forces. So in this, if you see, if you disturb in the flight dynamics, if you disturb internally or externally, how the airplane is behaving in all the 6 degrees of freedom. So that is called the stability and control. So if this is the aircraft and you are flying like this and some disturbance has come from the wind, assume it is a gust. So if the gust is coming, your aircraft will change the present position and it may behave in different way. It may vibrate, it may immediately it can come down, or it may go away from its equilibrium. So this type of phenomena is studied in the flight dynamics, and that is also we say that aircraft stability and the control. And this course fully I have already completed. You can refer my YouTube video. If you talk about aeroelasticity, aero and elasticity means here aerodynamic forces as well as inertial and elastic forces, that is the material structural phenomena and the aerodynamic phenomena. If both are interacting, then this stream is called the aeroelasticity. And so these are the three things which we have to deal in flight mechanics. Now there are some requirement for the performance of an airplane. So if you want to see that airplane, so in the airplane you will have the first one is the takeoff. I think first one is the range. The range. What is the range? Range is the distance which an aircraft can cover for a given full amount of fuel. So if aircraft is moving from A to A with a full fuel, and it is maximum it can go up to B. So this distance from here to here, this is called the range. This is called the range. So we can define that range is the maximum distance which an airplane can cover by given full amount of fuel. That is the range. The second is the takeoff distance. So if you see here how the very important parameter is the takeoff distance. So first we will about the range. So the customer will give how much I want, the customer want how much distance your aircraft, my aircraft should travel in a given amount of fuel. So if it is a local or in the domestic flight or international flight, so if you want to go from long range, your aircraft range should be decided accordingly. Okay. The second is the takeoff distance. So every aircraft has to be on the runway and it has to take off. So starting from here, it has to run and it should be able to obtain some velocity, and after that it will start climbing like this. So this is called the takeoff distance. Takeoff distance. So second one is the stalling velocity. Means if your aircraft is flying, what is the minimum velocity at which aircraft will be able to sustain in the air? So this minimum velocity is also very much important, because if you are flying below this, aircraft will not be able to sustain, aircraft will not be able to produce that much of the lift which can sustain the aircraft afloat. Next is the endurance. So this endurance is that time. So what is the endurance? Endurance is the maximum time in which aircraft can be afloat or on air. So how much time, maximum time aircraft is flying? It is from the takeoff to the landing. How much time your aircraft can sustain in the air in a given amount of fuel, in a given amount of fuel. That is called the endurance. So this is the minimum velocity, and there is a maximum velocity also. So maximum velocity, if we see that how much velocity your aircraft, how much speed, maximum speed an airplane can achieve by full thrust. Full engine thrust you give, and how much velocity maximum it can achieve, that is called the maximum velocity. So for any designer, if you want, he will give some requirement of maximum velocity. Then next is the rate of climb. Means per unit time, how much altitude an airplane can obtain. That is the your rate of climb. So it is from here, it is climbing. So this is the height, h per unit minute I am writing here. So h per unit minute means height per unit time, that is the rate of climb. Next is the combat. Some military aircrafts are designed for some fighting role, for dog fighting, for the maneuvering and all. Those things are called the combat capability. So this, the customer requirement the company has to meet. Then maximum load factor. So load factor is the L by W. Load factor, it is called small n. This small n is equal to lift divided by weight. So this is called load factor. So how much maximum load factor your aircraft can sustain. So for a cruise flight, n is required just 1 or 1.1. But if it is fighter aircraft, your load factor may be 10, 11, 12. For your normal, your passenger aircraft, it is 5 to 7. So like this, we have different types of load factor as per the requirement. This shows that how much you have the load factor, that much different maneuvers it can perform. That is the meaning of load factor. Now the next is the service ceiling. So service ceiling is the maximum height. If suppose this is the your earth, aircraft can go for a certain height. This is the service ceiling. This is the height. This is the h, as I am writing. The height up to which the rate of climb is maintained as 100 feet per second. Every aircraft is designed for some rate of climb. So if this rate of climb from the ground to a certain height, the designed rate of climb can be achieved. Mostly it is 100 feet per second. This height is called the service ceiling. If you go beyond this, you will not achieve this rate of climb. The rate of climb, as you go up and up, it will be reducing. After some time, it may be 80, then 60, then 50, and you will reach some height where it is called absolute ceiling. Absolute ceiling. This is the height, absolute ceiling. Beyond this, aircraft will not go even 1 meter above this height. So that is called the absolute ceiling. So absolute ceiling, above that aircraft is not possible to climb. But from the service ceiling, it can climb, but the rate of climb will be reduced from 100 feet per second, or the designed rate of climb will not be achieved above service ceiling. But aircraft can go up to absolute ceiling, but after that, it cannot climb beyond that. So that is the meaning here for the service ceiling. Next, very important factor is the cost. For anything, the cost is very important. Means how much money you have to spend for a given. If it is very good aircraft, but it is very, very costly, people will not afford. So try to make the aircraft in a given price. So that is the very important performance requirement. Reliability and with the maintainability. The aircraft which is to be designed for a certain task, that task it should complete with a 100% reliability. It should not fail at any condition. So that is called the reliability. And the maintainability is the ability of the aircraft to maintain easily, easy to maintain. That is called the maintainability of the aircraft. So if it is easy to maintain, the cost of the maintenance will be reduced, the time of the maintenance will be reduced, and this all will make the aircraft very attractive, and the performance of the aircraft, the availability of the aircraft will be much more if it is not properly maintainable aircraft. Maximum size, we cannot make aircraft as our wish and will, that 100-meter long or this thing. This is depend upon the availability of space, like your fighter aircraft, if it is for Indian Navy and all, or the for so the size you cannot make very big, because you have to put inside the hangar or inside your deck or the flight deck where your aircraft has to take off and land. There are some hangars. The hangar doors are also the limitations. You cannot make as per your choice. So the size of the body, size of the wing, size of all the things are very, very important. So these are the some performance requirement, and we will discuss again for the basic definitions of these basic requirements. So range, aircraft range is measured in terms of distance and quantifies how far an aircraft can fly based on a given amount of fuel available. So how much is the fuel available? From that, the aircraft, how much distance. So the range is measured in the terms of distance and quantifies how far an aircraft can fly based on a given amount of fuel available. Next is endurance. In aviation, endurance is the maximum length of time that an aircraft can speed in cruising flight. So how much speed it can fly in a cruising flight. That is called the endurance. So endurance is the maximum length of time. How much maximum time it is taking for a given amount of fuel. Stall in aviation, when the angle of attack suddenly increases beyond a certain point such that the lift begins to decrease, it results the stall. So as you increase the angle of attack of your aircraft, so this is your angle of attack. As you increase from a certain angle of attack, assume it is 20 degree, the lift will be reduced. So initially it is going, so this is your stall angle, it is alpha stall, and this is the CL. So the angle at which you are getting the maximum coefficient of lift, that is called the stalling angle. If you increase a small angle, your lift will start decreasing like this, and your aircraft will start sinking. So this is called the stall. Now rate of climb. The rate of climb is a rate of change in altitude. So per unit time, how much vertical height your aircraft can travel, that is called the rate of climb. Load factor, the ratio of the lift of an aircraft to its weight is called the load factor, and it is represented by N. N is equal to lift by weight. Now the service ceiling. The service ceiling is the maximum usable altitude of an aircraft. So all I have discussed just now. So this is the ground. From here to here, it is a usable altitude, and this is called the service ceiling. So up to here, you will have all the rate of climb will be obtained. Whatever designed rate of climb, mostly it is 100 feet per minute, per second, sorry. So it's able to fly that much. So that we have to ensure. Absolute ceiling, the absolute ceiling is the highest altitude at which an aircraft can sustain a level flight. So up to here, if you further increase from here onwards, your aircraft cannot go above this. This is the maximum height at which your aircraft can go into cruise or steady level flight. It can achieve. Not the climbing is not possible. Reliability is defined as the probability that a product, system or the service will perform its intended function adequately for a specified period of time or will operate in a defined environment without failure. So reliability means if it is designed for 15 years, your aircraft should perform all the functions without any delay or without any problem. So this is called the reliability. Combat is most commonly used in military context to refer to active fighting among opposite armies or an aerial battle between fighter planes. So between fighter planes or aerial air attack and all these combat modes are used for different purposes. Now I will discuss about aircraft mission profile. The mission means what type of work it can perform. We have different types of missions of the aircraft. I am going to discuss some 3 to 4 mission of the aircraft, and that time we will see that how these things are working. Typical mission profiles for various types of aircrafts as shown in the below figure. So it is the first case is a simple cruise. In this simple cruise, this you can see here. This is the simplest case. General aviation aircraft, airplanes use this mission profile. Okay, so what is the meaning of here? That general aviation means the aircrafts which are small in nature and they are used for different purposes like training purpose, like agricultural purpose, recreation purpose, firefighting purpose, some defect solving or some other tourist purpose, transferring from one space to another space. This all work, your medical purpose, these all things are called the general aviation. And the general aviation aircrafts are very small and they will just take off and they will land only one place. They will not go in multiple places. So here 0 to 1 is a takeoff. Here aircraft will start running. From here aircraft will get certain amount of speed. If it is getting that speed, then it will nose up like this. So initially it will run like this, then nose up by the elevator. It will start the climbing like this. This is called the climb. So 0 to 1 is a takeoff. 1 to 2 is a climb. After reaching a certain height, it will go straight and level flight. That flight is called the cruise flight. So here it is the cruise flight. After reaching to the destination, aircraft will start some 50 miles or before. It will start descending. So this is called descend here, from here to here. Once it is descending, then ATC may not permit the aircraft to land. ATC will give the instruction to loiter around. Your aircraft will be circuiting around this is your airport. ATC will give some altitude and some distance from and it will give some area. Your aircraft will start circling there. Number of circles also may required, and as and when the runway is clear, ATC will give the permission to land on the runway. So it is 0.6 here, and after this is the landing. Descend, and after that it is aircraft is landing. So it is a small aircraft. You have the landing also very small, and the takeoff is also comparing to. You can see the distance. Takeoff is more than the landing because the weight of the aircraft is reduced now. The fuel is consumed, so the weight is reduced. So your takeoff distance is also, your landing distance is reduced. So as per your requirement, you can see that how these things are working. So this is the simplest case for the cruise flight. And now we will see the next, that is the commercial transport. We always fly with some Air India, Indigo Airlines, SpiceJet, Akasa Air, and so many other foreign airlines are there. They all are the commercial transport. they are used for the multiple purpose. This you can see, and multi-airport it can go. So if you see, there is a little difference. This one was not there. Now this is introduced here. So from Hyderabad to, you want to go to Amritsar, in between you may have to land somewhere, Bhopal, Indore, New Delhi, then you can go to the Amritsar, and same way the back. So here, first is the takeoff. It will take off on the runway, then it will climb. After climbing, it will cruise. When it is reaching to the first destination here, it will start descending. After reaching to certain height, pilot will ask the permission to land, and if it is not permitted to land, ATC will give you the loiter zone. You start circling your aircraft there. As and when you get the permission to land, it will come to the direction of the runway and it will land here. Again, boarding and deboarding of the passenger is done for some time, maybe 15 to half an hour, and then again it is taking off here. Again it will climb, again it will divert. From here again it will loiter, and again it will land. So like this, different missions are there, and this mission is called the commercial transport mission profile. So the aircraft has to be designed for commercial in a different way. For a long distance, we may have to use the jet engine, we may have to use the propeller engine as per the distance to be covered. So the designer has to understand this, all the mission profile of the aircraft. Now if I talk next about the low-level striker airplane. Low-level striker airplane means they are the military aircraft, they are the fighter aircrafts, they will fly, they will hit, they will come down to low level. From there they will fire the bombs or some missiles and all, and like this the profile is there. So this you can see here, it is not landing on the ground, but maybe some 500 meters or 1 kilometer or 2 kilometer above the ground. So takeoff is same, then it will climb, then it will cruise out, then it will loiter, then it will drop the bombs or drop the items, again it will climb, it will cruise, again the loiter, and it will land. It may land in the same, or it may be landing in other places. It is not as per the mission requirement, and it is as per the pilot's brief from his commanding officer or the instruction given by the senior officers. Pilot will decide where to land, where to not, where to do, and where to drop the items and all. These all things are called, and they are the low-level strike airplane. Next, I will discuss about air superiority airplane. Air superiority, they are much powerful, and they will do the dog fighting, they will do some maneuvering face to face. 2 aircrafts or 10 aircrafts, they will fly together and they will do some maneuvering and they will perform some missions. So here they will also drop some item, but they are not coming very low. They are from height, they are releasing, especially the missiles are released. So they are taking off, then climbing, then cruise out. Then here the combat mission, fighting between one aircraft, another aircraft, number of aircrafts, and they all will do some combat operation, and this is called the combat here. And after that they will perform, if they want to drop some missiles or some guns, some bombs, they will do that, and then they will cruise back and they will go to the next place, they will loiter there, then they will wait for some time, and then they will land. So like this, it is the air superiority airplanes. So we have discussed here 4 types of mission profile. Now I am going to discuss about the component of an airplane. We know that the airplane is made of number of components, and every component has got its own functions, own purposes. So we will be discussing about each component of the airplane. It is very much essential to understand that what is the function of each and every component of the aircraft. So I am displaying here the component here. And you can see here that I will start from this nose. It is a cockpit here. In the cockpit, the pilot is accommodated. All the equipments, instruments are there. All the meters, gauges, all the monitoring things are there. And it is called command and control is performed from the cockpit. Next one is the fuselage. It is the body of the aircraft. This you can see from here to here. This is the whole body. This is called the fuselage. This I have mentioned as a here. This is called the fuselage. This whole body, it holds the things together and carry the payload. The purpose of this fuselage is to accommodate all the items, all the instruments, all the radars, everything is accommodated inside the fuselage. Next we can see here, it is a slat. These are the slats. They are used for increasing the lift of the aircraft. Then we have here a spoiler. These spoilers are changing the lift, drag and the roll of the aircraft. These three functions are performed by the spoiler. We have here aileron. Ailerons are done for rolling of the aircraft. If you want to roll aircraft, so if you want to do like this, your aileron has to be deflected. Then we have here flaps, change lift and the drag. Okay, so if you want during takeoff and the landing, we want to increase the lift. That time these flaps are lowered and the camber of the wing is increased, and that is making the aircraft to make up. Elevators change pitches up and down. So here the elevators are making pitch, nose up and down. Rudders change yaw, side to side. So if you want to make nose, it is done by the yaw. This is a vertical stabilizer. This vertical stabilizers are used for stability. Yawing stability and the rolling stabilizing is achieved by the vertical stabilizer, and the control of yaw is achieved. This is the horizontal stabilizer. This is making your pitching stability, and it is making the aircraft stability in a pitch. Then we have a wing. These wings are used for generation of the lift. The total lift is generated by the wing of the aircraft. Then we have the engines here. One is here, another is here. So it is called jet engine, and this generates the thrust of the aircraft, and in this way the power is obtained, and this power is used to force the aircraft to move forward. The locomotion is achieved by this engine. In this way I have completed all the major component of the airplane, and I have also discussed about different parts and their functions of the aircraft. Hope this will be quite good. So I am using these references: Anderson J.D. Junior Aircraft Performance and Design, International Edition, McGraw-Hill's first edition. Iselby M.E. Aircraft Performance Theory and the Practices, AIA Education Series, AIA second edition. Thank you very much for this joining. Any questions you are welcome to ask. My email is yddwivedhi@gmail.com. Any questions you can send me. Please do like and subscribe this channel. And if anywhere you feel that it is not clear, please do ask. I will try to check it, and I will try to modify these things. Thank you very much for the joining, and be tuned for my next lecture. Till then, goodbye. See you again.
Like, share and subscribe. Hit the bell icon for more updates.